Hi, this is Kevin. Welcome back to another video in our series about the Indiana Computer Science Standards for grades K through 8. Now this third strand, programs and algorithms. I've really seen an increase in this over the last few years because we start getting into more of the programming and coding type conversations. So let's break this down. In grades K to 2, here are the standards. PA1, use technology and developmentally appropriate multimedia resources to conduct age-appropriate research and support learning across the curriculum. PA2, create developmentally appropriate multimedia products with support from teachers, family members, or student partners. And then PA3, arrange information using concept mapping tools and a set of statements that accomplish a simple task. Now the first two, they're pretty similar to the network and communications standards that you'll see, but there's a less focus on the collaboration part and more focus on the individual creation of products. That third part of the standard means being able, as students, they need to be able to put things in order and able to accomplish a task. So here's a couple of activities down in the description. Some free activities. Safe Search Kids, safesearchkids.com. It's really kind of a Google engine powered safe search engine for kids. It's a great way for them to conduct research in a kind of a safe environment. Code.org has some really powerful lessons as well about conducting research and then also putting things into order in both a plug or unplugged environment. Let's switch gears and go to grades 3 to 5. In this, their programs and algorithms, the first standard is to use technology resources like calculators, data collection probes, mobile devices, videos, educational software, and web tools for problem solving and self-directed learning. General purpose productivity tools and peripherals to support personal productivity, remediate skill deficits, facilitate learning, and individual collaborative writing, communication, and publishing activities. That's a mouthful. PA2 is use digital tools to gather, manipulate, and modify data for use by a program. And then PA3, implement problem solutions using block-based visual programming language. Now the first standard there really calls for students to become proficient with Productivity Suite, whether it's the Microsoft Office Suite or whether it's the Google Suite, for individual creation, and then leverage technology to embark on a path of learning in ways that are more meaningful. Now in my mind, an example of that second standard, using tools to gather, manipulate, and modify data, would be researching online, copying the relevant information, text or otherwise, pasting it, and then remixing it to meet your needs. And number 3 is all about learning the fundamentals of coding. So we got some great resources here, starting with Google's Applied Digital Skills, an amazing program that gives students some authentic ways to learn and practice those skills. Code.org is a great one for as far as the understanding the block-based programming. Scratch, the initiative put forth by MIT. We did it a lot with students this year in grades 3 to 5. It really lets them truly create in an open environment using block-based coding. And then Google's Computer Science First program. Very comprehensive, great way to get kids into that problem solution environment. So those links are in the description below. Now we're going to jump to the 6 to 8, okay? So for our middle school students, PA1, select appropriate tools and technology resources to support learning and personal productivity. Publish individual products and design, develop, and publish data. Accomplish a variety of tasks and solve problems. PA2, implement problem solutions using a programming language that includes looping behavior, conditional statements, logic, expressions, variables, and functions. And then PA3, demonstrate dispositions amenable to open-ended problem solving and programming, like comfort with complexity, persistence, brainstorming, adaptability, patience, propensity to tinker, creativity, accepting challenges. Okay? So number 1, really becoming proficient with some sort of Office suite, whether it's Microsoft Office or Google suite of programs. Number two would be going beyond block-based coding, okay? Or at least, if you're still in that block-based coding environment, using more complex commands such as loops and conditions. And then number three, we need to make sure that kids are spending enough time with programming and coding, and it's rigorous enough that they can exhibit those foundational elements of problem solving, okay? So code.org, another great resource, they have a complete computer science course that students can take, kind of gamify things. Code Combat is another great resource. And then I've also got Common Sense Media. They've put together a list for educators and parents about the best coding tools for middle schoolers. So this aspect of comprehensive computer science is pretty overwhelming and daunting to teachers, okay? We aren't typically comfortable teaching what we ourselves don't feel confident about. Luckily, the resources I provided here allow us to learn as we go. And who knows, you yourself might discover something in yourself that you never realized before, that you are a budding programmer. And as the role that technology plays in our everyday lives continues to grow, so does the need for programmers in order to keep improving these systems and products. Let's prepare our students to be those next generation programmers that use their talents to create a better world through technology. See you in the next video.